Right, so this is the SDS1202X-E, which I'm going to have a little play with the issue with the input compensation. Now, to start off with, I'll look at the measurement side of things. So this is the normal scope probe, which I've got plugged in using a BNC adapter into a signal generator here, which generates 10 kHz. Alright, so that's giving 12 volts peak to peak at 2 volts of division, right? And you can see it's pretty flat in this case, okay? Now, something which is important is the probing method you're using, okay? So if I bring this out, you can see that's, you know, a nice ramped edge there, okay? Now, if I leave it there and I change the kind of probe I'm using, if I actually take this off, let's set it ×1 as well, obviously. If I get a different, this is just an RCA cable, 50 ohm RCA cable. Plug that straight in. And you can see that there's some ringing in here. It's got a faster rise time, but there's ringing, right? So you can get these distortions because of the cable, right? It's probably a bit too long, really, okay? It's probably why it's ringing. If I change it again to another cable, you see this one's got a big overshoot. Okay, so the type of cable you use and the way you're probing it will give you a big change in that what you're seeing here. Also, the rise time is really quick on those cables. What this is, see, this is a 75 ohm cable. Okay, this is RG59U. This is 75 ohm cable, not 50 ohm. So you have to be careful of those kinds of things to make sure you're using appropriate cables. Now this one here is a 50 ohm, not RG58U. Okay, so that's 50 ohm cable. So they should be giving you the best results, but not necessarily. So you've got that little bit of ring in there. Okay, so you know, yes, it's got a faster rise time than the scope probe cable with the BNC adapter. So this should actually be more accurate, really. But so you got some ringing. So the cable's a bit too long and things like that. So you know, it's not perfect. I'll go back to the original scope probe again. And there you go, it's got that slower rise time there, but there's no ringing. Okay, so that's just something to consider when you're looking at these things. Right, now part of the reason I chose these voltages, these are the voltages that you use for the adjustment of the scope when the capacitors have been installed. Okay. So it's all important you actually get these measurement systems right first, because if you're using the wrong cable, you may be misaligning it. Right. So if I had a 75 ohm cable on there by mistake, to be seeing that big overshoot, and I calibrate for that overshoot, you know, to be flat, which would be incorrect. So that's a purely matching thing, right? Now, there's cautions regarding doing the modification to this unit, and that is that there's high voltage inside it, so you have to be careful of that, and you have to take precautions about what you're doing inside the unit when you pull it apart. Being careful what you touch and making sure you don't expose yourself to anything dangerous. Another thing is ESD protection. So I've got an ESD mat here, so you know that's okay, it's already grounded. And you also need to make sure you use a earth strap for your wrist, right? So you don't build up any static charge either, because you don't want to accidentally damage the electronics in this thing, because you know that'd be bad. You know, the idea of this process is to improve the scope, not destroy it. Now this is a demo unit from Rob at Taupeca Technologies. This is demo unit. It's actually one I reviewed originally when they first came out, so it's exactly the same unit. Now this has already been apart, so you might see a few things there, like you know there's no warranty seal on it already, that sort of thing, because it's a demo unit. Okay, so, you know, Rob's look inside it and that sort of thing. So again, you have to make sure you use static precautions. You know, static mat, anti-static mat, wrist strap, which is grounded. And when we get to the high voltage stuff, and I open it up, and you'll see all that. You have to be careful of what you're doing there, and you know, nobody wants you to get electrocuted, so we want you to be careful about what you're doing. Some people that are used to working around high voltage stuff, such as me, I'm not bothered by it at all. I'm completely comfortable with it because I'm careful what I'm doing anyway. But if you're new to it, you're not really used to working on power supply sections, because you do have to, evolve with it. Then you want to be really careful what you're doing and make sure that whilst you're stripping on it and working on it, you don't have power applied. Also, the capacitors can hold a charge, so you have to be careful that although the power's not onto it, you can still get a shock because the capacitor's got a charge in them. So it's still, even though there's no power plugged in, you can still get a shock off it if you touch the wrong thing. So again, you want to be really careful about what you're doing there and paying attention to, keeping your fingers clear of anything which could be potentially hazardous, especially when you're actually working on it. Another consideration is when you've actually got the thing apart and you've got it stripped, because the casing is off it, you affect the airflow, and so it doesn't have cooling on the ADC and things like that anymore. Right, the main processor just doesn't have any cooling across it anymore, and so things can overheat. So if you actually have to power it up, which you do have to do for the calibration part, without the casing on it, you have to do that for as short a time as possible because you don't want to overheat it. Ideally, you have a fan blowing across it to help keep it cool, just to reduce the risk of overheating anything. But it's not like you can turn it on, leave it on for 5 minutes, sort of thing. You definitely don't want to be doing that because you will likely, damage it by overheating. It requires the airflow to keep it cool and not damage anything. Another thing as well, which I'd recommend you do in this particular case, if you're opening up something like this, take off any jewellery, rings, watches, that kind of thing. Like in my case, I've got a metal watch and a metal ring. Right. Normally I don't bother. I'm just careful what I'm doing, but because this isn't mine and there is, sensitive electronics in there, I'm gonna remove the metal that's on me, just in case I short out something. There might be a residual charge on a part, and you could short it out just by leaning against it or something like that, or just brushing your hand against it. So I recommend, if you've got anything like this, take them off as well. Alright, so let's start by pulling this thing apart. Now, let's have a look what we've got. So there's screws up here. This is the first time I pulled one of these apart, so it's going to be interesting. So we both get to find out at the same time. So there's two countersunk screws there, and you've got two standard screws here. So normally you have a warranty seal just here in the bottom. Let's say Rob's opened this up now to look at it, so that's already been removed because it's one of his demo units. So the alarm just went out for testing. Right, so that's those screws that go on the bottom there like that. Again, let's put them out of the way. Now this, I think, should lift off now. I believe it will. So I'm missing something. Fingernails in there. Don't believe I'm missing anything. So he's lifting off. Just this end here is a bit tight, I think. Just to see, I think there's a clip at this end somewhere. Here we go. Yes, hook clips. Okay. So that's that. Now, so if the feet fall out, let's watch out for that. Pop them back into the cover. I'll just pop it back in like that. Yeah, okay. But I must have just popped out because I was leaving on it. So that's the feet back in and cut it around. Don't lose those. So here's the metal casing on the body of it. You've probably seen a teardown from Dave anyway. He's already had one of these things apart. I have actually watched that, so it's not completely foreign to me, but this is protecting you from touching the power supply. Okay, kind of important because that's a dangerous bit. Now, what screws we got here? We've got screw there, that's it, one each end. Okay, and we've got the housing there which goes over the top as well. So how do we do this? Let's see. I think we take off, let's see how it's attached. I think I should start with the easy bit, eh? That makes sense, doesn't it? Let's start with the small panel and we'll go from there. Now the countersunk screw is the same one as is used on the top of the case, same size. I haven't got my wrist strap on yet because I'm not doing anything which requires static protection, because it was getting away at this stage, but I'll be putting it on very shortly. Let's put that on there, here we go. Okay, so there's the metal cage off. Right, so there's the power supply, and there's the main board. Alright, so definitely don't touch it until you've got an anti-static strip on. Okay, so inside here is the input section, and we'll have to pull this apart. So it's just stick the strap on, got it ready to go. So what's the next stage here? So the top cover here can come off, which exposes the top area. We've also got the screws around the outside here. There is actually an information download for how to pull this apart. Okay, so I've had a read of that document, and the basically it says what I was thinking of doing: taking the top panel off, taking the power supply out, and taking the screws off and removing the whole assembly. And then you got to take off the BNC connectors on the front. You got some nuts on and stuff in there. So that's all straightforward. It did actually mention in there pulling off all these knobs, right? I'm thinking, well, I don't think you actually need to take those off. So I'm going to see how I go. I think that's actually the first step, is pull the knobs off. And I'm thinking, from what I can see, I don't think that's correct. So I'd say leave the knobs on, because I think that's wrong. Okay, and we'll go from there. So let's pull it apart. Now this unit here, I should actually say, Rob has had this apart. Oh, I think I mentioned it actually, and he put it apart to have a look at it to see what the story is with it. So so there's bits of tape that are normally on the connectors and things like that, which are not on there now because he's taken those off to get the connectors out. So you know, just don't worry about it too much. I'll point those out soon. So so just down here, let's get this trim tool. You got these two ribbon cables. There's normally tape on, at least on this one. I think he said it might have been on both of them, but he took that off to get them out when he pulled it apart to check it out. So there's normally tape on there, so normally you have to peel that off when you pull that apart. Okay, so let's take the top cover off. Now if you actually have the top cover off, you can actually see, well I don't know if you can see because the light's probably not the best, I'm afraid, but down there's the hole for the adjustments in there. So once we do that conversion, well that addition of the capacitors in there, you can get to the trimmers. So you've got trimmer 1, trimmer 2, I think it was in order, 1, 2, 1, 2, which you set up on the voltage ranges as per the document. So the actual procedures are linked in down below. They're actually documented quite well on the EV blog forum, in the compensation issue thread. There's links straight to the post from Tautech with the documents. One is the disassembly document, which shows how to pull the casing apart, which is what I'm doing now, and one is for the capacitor information. It states all the capacitors as well in the document. It states the ones which are available. You can get them from Siglent. Siglent do supply them, and the calibration of these trimmers and how to set those up as well is also included in it. So, which is what I'm also doing in this video. So what I'm doing here, watch it by all means to give you an idea, but make sure you download those documents and actually follow them. One thing it does mention is using anti-static gloves. Well, I don't have anti-static gloves. I've only got this wrist strap, which I have to plug back in again before I do any further. But so it's all pretty straightforward, I think. So I've got to pull this power supply out. So let's now touch electronics parts. Let's get myself grounded again. Right. So the power supply looks like it's got 4 screws there. It's got an earth strap we have to unplug. It's got the main connector here which you got to unplug, and a couple of screws on in there to take out. So we'll start with those. And then we shall take those other ones there out. Let's just take the connector off first. We've got it out now. So Rob's already had this apart. So the adhesive glue on these, which is used to help secure them, has already been broken, I suppose. The glue's been removed. So that's why it's coming apart. Let's take this strap off, we'll forget about that. Do the top one there first. So I don't believe you need to take the knobs off. From what I can see, it's not necessary. So we shall see if I'm right or not. We'll get the power supply out of the way first, then we'll go from there. And I pulled lots of things apart, so I figured things out without instructions. I could easily got this apart without instructions, but I just want to double check to make sure that I'm doing it the way that Siglent recommend doing it, basically, the standard disassembly instruction. Alright, so I think that's all the screws. Yep, so power supply out. This has been off for a while now because I had to go away and do something. So yeah, definitely be careful what you're doing. Don't touch the edge of the board. There still could be charging this capacitor here, or that one there. There could be power in there still. So what's that? Lelong cap. Okay. Anyway, so I'll put it over there out the way. So that's that part out. Now we've got a shield here we've got to take off, the looks of it, because you've got to get to these ribbon cables to get those out. So you take the shield off, a couple of screws there. Okay, that slips out of the way, that's nice. Okay, so here we go. So you can see, hopefully you can see the sticker residue here from the tape that used to be on there, where say Rob pulled it off when he stripped it the first time around. So let's unhook these. So you've got the two lever arms at the end, so just pop these up. Standard ribbon cable connector kind of thing. As you can see, it's got a ferrite attached to the chassis here, it's glued to the chassis. Or it's double-sided tape or something like that stuck to there. Right, so you have to make sure when you do this, you've got to feed it back through that ferrite. Put this up as well. Make sure both sides are released nicely. They should just come out nicely. There you go, nice and straightforward. This one here, yep, that's out. So that's all out. Now we've got the fan assembly here because we've got to take this board out of the chassis as well. I'll do that in a minute. So I think that's all I can do there to get that free. I should just be able to take the screws off the outside now. So we got 1, 2, 3, 4, 5 screws. Yep, that's also in the manual too. Which I did read it, but I've not memorised it. I just got the content, you know. So Dave has pulled this apart as well, so if you're not sure, look at Dave's teardown too, if I haven't covered something well enough. And one theory this should allow me to pull the chassis part out from the front. If it does, then I'll stop there and move on. Oh, yeah, okay, we have movement. All good. So let's pull this over here. You've got to feed these ribbons through so you don't damage them. So let's try and feed that one through as I pull it out. Because it's kinked over, it might put stress on it, so I have to be careful. Here we go. Right, there's that one there. Okay, that's sliding out nicely. Here we go. Alright, so that's front panel off, and sure enough, you don't need to take all those knobs off. Alright, so you can ignore that first step in the instruction. So, now we're ready for the next bit. Now, I've already got a socket here and a ratchet, which I think I probably need to use. Yeah, I'll do that first. So we've got the nuts on the front here, we've got to take those off. Now these are 16mm or 5/8. Now I've got a 5/8 spark plug socket here. It's a deep socket, so I should go over the BNCs. So in theory it should fit. Right, so yep, that goes. Now let's get the ratchet on here. Now my ratchet's a bit crappy, but it's the size I've got which will fit. So let's give it a go. Cool. Right. Bring this one on. Cool. Right. Should have these by hand now. Sure enough. Come on, how'd you come? This gun's not cooperating now, is it? So you've got that, and you've got a little lock washer. So all three are the same. Let's raise that right. Right, so that's those off. Now I should be able to take the thing out of the chassis. Now I've got this wire here I've got to get off, which is the fan. I should be able to pull it off my fingers. Sure enough, it's the fan off. So screw it over again. So screws we've got, let's see, there's one there, one there, one there, one there, and one there. I think that's it. So my screwdriver is magnetised slightly. It's a good thing to do when you're pulling things apart. Okay, so that should be that free now. And sure enough, it's moving around. Let's leave it a front there. There we are, it's free. So she's out. All good. So there we are, and there's the panel, and we've got to take that off to get to the inside there. Okay, so once you've got the board out, then you have to get this panel here off, which is a bit easier said than done, I suppose, but it's got a lever out from here somewhere just to get it started. Then I think once it starts, then you're okay pretty much after that, as usually would be the case. There we go. Right, and see, inside here are the places you need to look for. So there and there are the spare positions for the tuning capacitors for the compensation. So those have to be installed there. So that's what we've got to do, is put those in there. reinstall the cover over the top and piece it back together and do the calibration work, which is that's probably the hardest part. I think, is doing the calibration part, because you've got to sort of make sure the power supply is safe, you know, off to one side, so you're not going to touch it or short it out against anything. These cables on the head display, you've got to be really careful of those, you don't pull on them and that kind of thing. Alright, so it's all very fragile. So now I'm ready to install the capacitors. So, back on again. So I've got one here already. I've already cleaned up the pads a little bit because I don't think it's got lead-free solder on there originally. Freshen up the iron a little bit. Obviously my iron is ESD safe, earth tip, things like that. So I always want to tap on earth points on the board as well, just to neutralise any potential ground paths. It just helps to make sure it's all good. Now what I'm going to do is going to put a little bit of solder on one of these pads here. Now these pads have got, one's an earth trace and it's got quite a bit of mass to it. I found when I was trying to clean them up there, it took quite a bit of heat. So I actually want to put my iron up slightly because it was a bit low. Get that right. Come on. There you go. Get my iron set up. Be helpful. So I've got it slightly higher. I normally run about 350 when I'm doing stuff, because I'll just do it quickly, but this ground plane was even struggling with that, so I'm going to 360, just slightly higher. And what I'll do is I'll put a little bit of solder on that pad, and I'll position the capacitor and get it seated onto the board nicely, solder on one end and I'll solder the other end and just go back and just make sure it's nice on both ends. And I'll repeat that for that one. So I'll start with this one here first. A little bit in there. And this solder's got some good flux in it already. And so I've already cleaned the pads up a little bit. And yeah, it's definitely got some heat being sucked out of that. So I might even need slightly more heat. So I've got quite a small tip on this iron. So obviously it's losing a bit of heat from that. Okay, because there's a big ground plane there. Alright, so I've got it on 370 now, so it's gone slightly higher again. And I don't want to go any higher than that. That should be enough. So actually I might need different tweezers. These ones are bulky for this, but we'll see. Here we go. Right, so I found one of these other tweezers. I can't find my other ones, my black ESD ones, but these should be fine. They should do the job quite nicely, I suppose. Finer point at least. So we shall get the cap back to where I was, and we shall heat this pad up a little bit. Just get it pre-warmed, and then I'll drop the capacitor into it and touch it up again. So it's got this large thermal mass on this ground plane here, so it's a bit harder. So let's drop it down. You won't be able to see this, I'm afraid. I can't really get a good camera angle because my hands are going to be in the way of whatever I do, so we shall do this as best I can. Hopefully you get the idea at least. And it's a little bit fiddly. Probably lost that thermal mass I put into that pad now. Anyway, figure it out. Okay. And also you have to be careful not to touch it, the iron, against anything else. It's quite tight in here. Okay, get it positioned. Now slightly crooked. Let's see if we'll fix that. Okay. Right. In there. In there. A bit excess solder on this, let's clean this up. Once I've finished getting it in nicely, I'll show you the end result. The trickiest part about this is that it's got a big thermal mass, so it makes one end really hard to solder because of the fine point. But you also need the power in it to actually do it. So that's not bad. Come on. I may stick some flux on this actually, just to help it. Just a little bit. Won't be much. Yeah, it's better. Okay. I'll bring it up here so you can see, hopefully. Right. There it is right there. Okay, so now we can put the thing back together. At least enough to use it. Yeah, that's what we're up to. So I need to do the calibration once I've got it partially assembled. So let's get some screws in. Now, as always, when you put the screws in, don't do them up tight when you first put them in. Just get them in so they're located and threaded in a fair way. Maybe touching the board slightly. But don't actually do them up tight, otherwise you might have issues with alignment. Okay, so let's put those screws in first. Then I should put the B and C connector nuts back on the front, so that pulls the ball forward, and then I will do the screws up. Okay, because the assembly part of it isn't actually mentioned in the description about the best way of doing it, so this is my recommendation of how to do it. So that's that. Put the B and C's back together. Now, what I did notice when I was looking at this just now is that these B and C connectors, they don't actually butt up against the front properly. So I wouldn't do these up tight. They weren't that tight when I went to undo them anyway. So then say Rob said there's a part, so I'm not quite sure how the factory setup is on this, but from what I can see, the actual is like a recess. It's got this folded metal here, and it's got punched on the inside and the outside, right? And these are slotted, so obviously they allowed for some variation in design, and which shows forethought, I suppose, thinking about changes. Anyway, let me get this nut on. So what actually is that the bottom of the seat of the standoff is flush with the edge of the board, right? But what you've got is a square hole inside behind this. Alright, so you've got the rectangular one here. There's another one behind it inside this sheet, which is folded behind it, alright? And that means that there's actually, when you do this nut up, it's not actually pinching that metal. It's pulling the metal onto the edge of the circuit board. Okay, so there's a slight thing there to watch out for. So I don't think these should be done very tight. I think probably hand tight with this will be sufficient, because otherwise you're actually pulling the circuit board onto the edge, which could potentially be stressing the solder joints on the B and C's, because they're not actually mechanically pinching the metal in like you expect, from the seat of the B and C. So this is actually wedging quite nicely, but I think hand tight should be sufficient. I might actually just put a drop of seal on there so I don't loosen off. Alright, because I don't even actually see it in there, but you've got the body of the B and C there. There's actually got a gap between that and the front. It doesn't actually touch. So that's why I think over tightening these isn't good, because you're actually pulling the circuit board against the edge. So it looks like that's a bit of a potential design fail there, but only a minor. I think the B and C's are sitting further back on the board than they should be. They should be slightly further off the edge. But anyway, so I just want to mention that. Just watch out for that. Don't over tighten them, I don't think. Let's do the screws up. Now the board is actually located, pulled into place by the B and C's. Now the fan is actually here blowing across, so now Rob thought that it wasn't possible to do the calibration with it inside the chassis, right? Now I'm looking at obviously like this, and I think, yeah, actually I can do it inside the chassis. When that top panel's off then you can access it easily enough. It's straight down. You can see the trimmers in there. So I think airflow maybe not such an issue after all. Maybe just for the power supply section itself, because obviously you've got heat sinking and stuff on the power supply, so you don't want that overheating. So that's quite important. So maybe it's more of that which is a concern than the actual oscilloscope itself, the actual circuitry here. Okay, so I'm just going to double check. I think I did all those screws up. But I'm nattering away, so I better double check just to be absolutely sure. Yeah. Yeah, that's all fine. Let's get out of the way. Okay, so I think the next thing I need to do is to pop this assembly back into the front panel. Yeah, because then I can put this insulator back in, and it should basically be reverse of what I did when I dismantled it. Of course, we're assuming this capacitor is going to work, but it's not likely to be a problem. Now what you've got to be careful of, say, getting that ferrite, you've got to get this threaded through. So it's a little bit tricky by the look of it. Let's see. Because these cables are not sturdy, they're not really meant to be messed around with too much, so you have to be really careful with how you handle them. You don't want to stress them, you don't want to kink them or anything like that, because if you do, then you've got a problem. Okay, that's just coming through there. Get the other one threaded through here. Okay, I think that's bedding down. Okay, I think we're all good. That looks okay. So let's just screw this on the front. I'll stick one corner there first. There we go. It's actually got some little standoff posts there to locate it, so you have to make sure that's aligned. And that's not quite sitting down right. Why is it not sitting down right? Probably a B and C setting or something. Hold on a second. It's one of these stopping it. It's not quite lined in. Come on, in you go. There we go. Right, that's better. Never force anything, always just check. Because if you're forcing it, something's wrong. Not just on scopes, but anything you work on. If you have to force it, and you have to force it apart, then you're doing it wrong. Dealt with, so dismissed. All this, I'm recording, so don't talk. Right. Nice and tight. Doing too tight, I mean, I screwed into plastic after all, we don't want to strip that out. That's perfectly acceptable for this. It's not like something which is meant to go together and come apart lots and lots of times. So plastic, screws in plastic in this instance is fine. Okay, so the next thing we're going to do is put these cables back in. So let's make sure they're both pulled out nicely. Slip that in. There we go. And put this locks down like that. Make sure it's locked nicely. Yep, that's done. Pop that one right out. It's fine. Again, don't force them in, just let them find their own way in. There we go. If you force it in, you're going to damage something. Bend a pin or something like that, and that'd be a disaster. Okay, so that's locked in place as well. Okay, so again, it's going through the ferrite. It's all nicely lined up as it was per factory. Okay, so that's all looking good. And I'm now at the stage where I have to start looking at hooking up the power supply and looking at the calibration side of things. Right, so now this is where you have to be really careful, right? So actually I'll put this back in before I forget about it. Actually, I'll do that next before I move on to this. Let's just get this done. It sort of goes over those posts. You have to both at about the same level, otherwise it ends up being too short. Right, put the screws back in. In this case you can tighten them down because there's only 2 of them and it's only through a piece of flexible plastic, so that's absolutely fine. That won't be an issue with alignment. Okay, so that's that shield back in again. Right, so you've got to be really careful with the power supply part. Again, because this is a switch mode power supply. In my case it's running 240 volts. Alright, so when this is powered up, it can be a bit dangerous. Alright, now this is a static dissipative mat. I believe it'll actually be okay to have that sitting on the mat in this case. Right, I don't think this will be a problem with any issues on the power supply. I think it will be okay. I don't think it will burn through. I think the resistance levels on this mat are high enough to actually not be a problem. If you're really concerned about it, you want to put that on top of like a sheet of plastic or some other kind of insulating material, maybe, you know, some papers or something like that, just so you got that bit of peace of mind that it's not going to have a problem. But I think this mat's fine. I've done power supply stuff with this mat before and I haven't had any issues with it, so I'm comfortable leaving it on the mat like that in my case. All right, now when you're doing this you need to be really careful, right? Because once you've got this plugged into power, and once, even after you unplug the power, it's got the potential there to kill you. Okay, because these capacitors don't discharge straight away. There's a time period where they gradually discharge. I mean, sometimes there's drain resistors across the capacitors, but that's not always the case. Now, interesting, this power supply has got a extra jumper connection here, little connection there, J5, which is a little interesting. So it looks like it's got some alternative uses or something like that. Maybe it's using other things as well. But it's dated 2015. So maybe it is used in other scopes and stuff as well. So maybe it's got multiple functions and it just repurposed it for this as well, which is a sensible thing to do because it keeps your costs down. Alright, so you have to be super safe with this, right? Because this can kill you if you're not careful. If you have any doubts about working with a live 240 volts or 110 volt mains, whatever your country has, you know, if you've got doubts about that, then it's best not to do it. Get someone which is comfortable and experienced and knows how to do it safely. Right. This bit here you could do fine yourself if you've got electronics experience and you can do surface mount stuff. This is a 1206 capacitors, I should mention that, 1206 size. Was it the metric equivalent? I think it was 3216 or something like that, I think it was. I can't remember. It's in the document you can download, as I mentioned before. So as long as you can do electronic soldering on surface mount stuff, then you can do all this part absolutely fine. All right? But when it comes to doing this part, you might want someone which is more savvy around mains query. If you've got any concerns at all, don't do it. Okay? Because ultimately, I don't want you watching this video and then going to kill yourself because you're not taking enough precautions, or you've made a mistake because you weren't thinking about the fact you've got something here which can kill you. All right? So be very cautious. All right? Now, so this I can plug into here like so. Nice, that's plugged in. So again, that's the correct orientation because I have to spin it around. Now what I also need to bear in mind is that I need to get to the front of the scope, to the calibration, and to those adjustments. So I've already got a trimmer tool here, I've already figured that out. Okay, so this end here I think it was, yeah, that in there fits those adjusters. Right, so I can pop that in there and I can get to it and I can turn them. Let's make sure I get it on there. But I know I can do it, okay? I've already checked that before I put it all back together. It's a bit fiddly because there's a big hole there, which has got a lot of clearance for the adjusters, and you've got to get that onto there and try and see down there, that sort of stuff. So that's a bit fiddly. Be careful of that. Right. Once you are in the position to start doing this, make sure you are safe, because that's the main thing. Right now, I don't normally stress this enough on a gear that I work on when I'm doing my repair videos and things like that. You know, because I'm just thinking about what I'm doing, and if I think of it, I'll chuck it in as an overlay on the video saying danger, right? But as always, just be careful, because this is how to do it. So because this is a how to do it video, I need to make sure that people aren't going to kill themselves with this, alright? Or injure themselves or whatever, or blow their scopes up because they've left it, you know, sitting on top of something like that, you know, or it's moved or whatever. Okay, so ultimately, be careful. Okay. So now I shall look at setting this up to get ready for calibration. Now, I probably want to put a little fan over here to keep the power supply cool. So I might go and get a little fan. I'll set that up, but it may mean that I've got a bit more noise, you know, air noise, stuff like that, because you hear the fan blowing. I'm afraid that's going to be a consequence of what I'm doing here, because I want to make sure it all stays cool, because that's probably more important. Right, so I'll go and get that set up, and then we'll come back shortly. Okay, so I've got the scope hooked up to the power supply. Power supply has got power going to it. I've got the signal generator ready to go, set up as ready as per this document here, which says 1.2 volt peak to peak at 10 kilohertz. The scope is currently turned off because, again, you want to have this turned off as short time as possible whilst doing this alignment stuff, because you don't overheat anything whilst it's apart. Okay, I've got a fan going. You can probably hear it. Hopefully, it's not too noisy. That's just blowing across this whole area to try and keep it cool to reduce the chance of any issues. I recommend you do the same kind of thing when you're doing it yourself. Now, this is the actual document which you can download from the links down in the description, as supplied by Tautech. So these are the parts which are considered considerable. So it's either 4PF or 3.9 PF, 1206, which is a 3216 in metric, 500 volt C0G MPO, right? So MP0. Now that, as you saw before, that's in that position just there, which I replaced. So that's the one I did. And those are the two trimmers, right? So it's trimmer 1 and trimmer 2. This is obviously one channel block. The other channel block is next to it. Okay, so that's channel 1. Channel 2 is over here. So I'll do exactly the same thing on this channel. Right, so I'm going to do one channel at a time. You can do both at once, but I'm just going to do one at a time. Turn it off, give it a chance to cool down, and then do the other one. Okay. Don't rush this, it's not worth rushing it. Now you may need to go from one to the other. You might need to go between each trimmer. You might have to go backwards and forwards until you get a good match. So it's one of these things, just so that it's the typical alignment stuff. You go from one to the other and just get the best you can between them, based on what the description is here. Right, so it says about tweaking the variable capacitors in the front end may be necessary after the rework. It may not be necessary if they're already adjusted closely enough. You may find you go to the test and it's actually fine. Just putting a capacitor in is okay. You may not need to make those adjustments, but again, you may have to make the adjustments. Okay. Because the solder may change the specification of some components slightly in the front end, especially variable capacitors. Right. So because you've heated up the board, got flux in the area, and obviously your IPA, clean that off again. You may have left a little bit of residue which will affect the circuit slightly. Okay, it's possible. Obviously I've cleaned up IPA on there, cleaned all the flux back off again, so it's all nice and clean, right, as it should be. I didn't show that, but I probably should have done. But it's all been cleaned off as anyone that does this kind of work should do. And a quick look and decide if the tweak is necessary. In other words, you're looking for this this compensation here, right? That's what you should be getting when you do this test. Okay, so and these are examples of bad compensation. So the first stage here is input a square wave of amplitude 1.2 volts peak to peak, not RMS. Be careful of that, peak to peak, right? And a frequency of 10 kilohertz. Set the vertical scale of the scope to channel to 200 millivolts of division. And this is important because you've got to make sure you're in the correct scaling for the adjustment you're doing. If you've got it set to the wrong one, you won't be making the correct adjustment, or you won't be adjusting it optimally. Okay. It's between range changes, so you've got to get that at the right point. Okay, so that's why it's 200 millivolts division. And check the waveform displayed and compare it with the one shown in figure 2, which is this. Right. The waveform display matches the perfectly compensated waveform in figure 2. No tweakers needed. Right. In other words, you're trying to get the nice pure square wave. Otherwise, adjust it. Adjust trimmer 1, okay, which is the one closest to the front panel. Then you've got to do the same thing again for 12 volts peak to peak. Again, not RMS, peak to peak. And then adjusting the scope to 2 volts per division. And doing the same thing again, but this time you're doing it with trimmer number 2. Right, trimmer 2, which is the one furthest back. And then you check for that. And then what we recommend you do is after you've done that, go back and do the first check again. Okay, because it is all interrelated, you may find there is one may affect the other very slightly. So again, go back, check one. If that looks okay, then you're fine. If you need to tweak one again, then tweak it, and then check 2 again. You might just have to go back and forwards a couple of times to get it right. It just depends how lucky you are with the positions you set the trimmers at. Okay. Then it also states, says, do steps above apply to both channels. So exactly the same thing for both channels. Do channel 1, then do channel 2. And then step 4 is doing a self-calibration. Now it says rework and tweak operations will not affect the scope calibration in theory, but due to potential drift caused by solder processing, as in the residue left over, flux, IPA, that kind of thing, right? It may have actually removed some flux that was left on the board, possibly. May have left it cleaner than it was when we started. So it is recommended to do a self-calibration after all processing has been done. Right, so after you've done that, done the calibration on the trimmers, then it recommends for half an hour. Actually, running for half an hour. Right, then do a self-calibration. So it's got a proper point there. So what I'll actually do is do all this calibration stuff here, both channels, reassemble the unit, leave the thing on for an hour. I'll be generous, do it for an hour, then do a self-calibration. Okay, and then hopefully all is good. Right, so we shall get started. So this is the first time I've done any of this. This is all, I haven't done one of these before, so you're seeing it as I'm seeing it. Now I've used a BNC cable, right, because as I showed at the very beginning, the scope probe, whilst it works and gives you a nice response, the rise time is a bit slow, okay, even though it's set at 1 times. So it's obviously having a capacitive effect on the input. So the recommendation from Rob is actually, obviously what he's heard as well, is just use a BNC cable. And then what I saw when I used this BNC cable is that the rise time is much faster and there's a little bit of ringing there. So as long as I watch out for the ringing not fooling me, the rise time being fast at least gives you a chance to actually see what's going on rather than being hidden by the rise time. Okay, because you're on a nice sharp corner on that square wave. Okay, so got the fan blown across, power supply is on. I shall hook up this just in case. Get my trimmer, and I might have to adjust my light so I can see what I'm doing. So I can see down those holes to see where the trimmers are. Well, variable capacitors is what they actually are. And the green ones. The green is 20 PF, if I remember rightly. Okay, so let's power the scope up. And hopefully nothing's broken, it all still works. The screen's on, so that's always a good sign. And all the panels lit up, so it's looking like it's all fine. Everything's plugged back in properly. The fan is plugged in. Yes, the fan is spinning. So I've got airflow through everything, so it should be okay. Now I've got this set up, so let's go 2 millivolts division. I don't know about the time base yet. Yeah, 2 millivolts there. Right, let's turn the output on. Okay, time base is right, that's fine. So that's actually looking fairly good already. Let's just spin this around a bit so you can see. Be careful of the power supply. Okay, so you can see it's actually got a little bit of a peak here. Right, but as I bring this out, it's disappearing, so it might just be a bit of ringing. So I may not actually need to do any adjustment there. Okay, that one's actually looking pretty good. Okay. But as I bring it in, you can see it's coming up very slightly. Very slightly there. So I might just give it a tweak and see what happens. Being spec round again because I'm trying to get the airflow across it. So on channel 1, on number 1. Let's try and get the trimmer in. Again, this is a tricky bit, is trying to get this onto the actual capacitor. It's not the easiest thing to locate onto. Come on. I do have a ceramic one somewhere, which might actually be better. But because of the flood, I'm a bit disjointed about where everything is. Come on, get in there. Come on. Oh, I think that's in. Let's tweak. Yeah, that's changing. Okay, let's bring this around so you can see. Hope you can see that. As I'm turning it, you can see the waveform changing. See that? So I need to bring this right down and try and get it nice and square. Okay, so obviously rise time is being a bit of a part of this. I might just try to go back slightly. Might be too much. So yeah, it's got a spike on the top there, so let's bring it back the other way. Okay, that looks pretty flat to me. Right. I think that'll do. Okay, so let's bring this back around. We'll do trimmer number 2. So let's turn this off for a minute. Let's give it a chance to cool down. Whilst I'm setting up the generator. Turn it back off for now. So now I want 12 volts peak to peak. Okay, again 10 kilohertz. Just want to make sure this is all cooling down okay. Don't need anything to get too hot. It feels alright. Chips will feel okay. Seems fine. I think I'm getting enough breeze from that fan. Might turn it back on again. Then we'll do trimmer number 2. So again, I've got to set the scope to 2 volts per division. So 2 volts per division. Turn the right way would be helpful. Turn the output on. We'll see what we're getting. Okay, so that's not looking too bad actually. That is not bad at all. I might leave that exactly where it is. I'm not even going to touch it. Yeah, that one looks absolutely fine. I'm not even going to touch it. Okay, so let's go to channel 2 and we'll do the same thing with that. Channel 2 on. So I'm going to do the 1.2 volts first. So I want 200 millivolts per division. And I need to set the trigger to trigger. I want it to be. Oh, sit down. Let's do it this way. Where are we? Trigger, source, channel 2. Oh, been past it. Channel 2. Here we go. Okay, menus. So, again, that's actually looking pretty good from that first one. Let me just check the input levels. So I don't full bandwidth. I prefer AC coupling always. 1 times probe. That's all fine. So that's all looking alright. It's nothing skewed or anything there. So that's actually looking bang on channel 2. So let's do the 12 volts. 12 volt peak to peak. Bring it level down some more. Again, 2 volts per division. And here we've got a little bit of rounding on the front edge. So it's actually looking a little bit undercompensated. Just there. So I'm going to tweak that one. Okay, we'll give this one a bit of a touch up. So that's the adjustment number 2, which we need to do. See if I can get it in here. I think I'm in it. Yep, I'm in it now. Okay, let's turn this around so you can see. Right, so you can see what I'm doing there. So it was slightly undercompensated like that. Now I'm bringing it up slightly flatter. So I'd say about there. Okay. It's looking about right. So let's go back to 1.2 again. And bring that level back down. Just double check that. That's looking fine. That looks absolutely fine. So I'm not worried about that at all. I think that's calibrated just fine. Okay, I think we're done. Let's shut it down. Pop this off for the time being. Okay, so that's looking like a success. Now something's just occurred to me, right? I've just refitted a power supply in this thing. Well, mostly, yes, I've got to put the earth tap back on again. Don't forget to put the earth tap back on. I was a bit distracted by the fact that once the power supply is actually installed, you can still access those trimmers, right? So you don't actually have to have the power supply out of the case. Now, this is what I was read about, description about how to do it is have the power supply out of the way and you know, do it that way. But you can have it in place, right? As long as you've got a big trimmer like this, so your hands are well clear of the power supply. You know, where mine are, you know, I'm working up here, well clear of it, nowhere near the power supply, then that's absolutely fine. Okay, you can actually have it in here, and that's probably safer than actually having it out, to be honest. As long as you've got a long trimmer like this. If you've only got a short trimmer, where your hand's going to be right here, right next to the power supply, then no, move it out of the way, put it on a surface to one side, as I did just now when I was doing the demonstration. Okay, so. But if you've got a long plastic trimmer like this, then certainly I think have the power supply in place, leave it in, because I think that is absolutely fine. I reckon you can get into those trimmers just fine without actually sticking your hands near the power supply. I think that's not an issue. Okay, so that's my recommendation. If you have a long trimmer, which is going to keep your hands well clear of this area, then leave the power supply in. And that just takes a bit of risk away. Okay, but again, if you've only got a short trimmer, like say something like this, okay, this one's no good, it's not the right tip, it's actually broken. If you've got something like this, then you're going to be right next to the power supply, and that's a bit dodgy because you might touch the back of the circuit board or something like that, and then that could be dangerous. So just something to bear in mind. There's another little shortcut there. But I'm going to put it back together now, put the cases on. Alright, so let's refit this. Kind of, there's end ones, they've got like a little slot inside there, the hole in it. You've got these tabs that have to go through those holes. So I think you've got to get those front ones through those holes first, like that. And push down, then you get those ones in. There we go. That feels good. Couple of those screws there. As you can see, I've got my strip back off again now because I'm not touching anything sensitive, so I'm not worried about ESD. I think I'll still work on the ESD mat. So we'll drop this one in place. Again, this has got little tabs all the way around, so you've got to make sure you get all those in. Again, don't force anything. If it doesn't go, just give it a chance to seat itself in properly. Usually just got to flex something very slightly like that. Okay, so that's all in there like that. Now it's got to put those end screws in. Okay. Put the panel back on again. No. Again, make sure those feet are in there because they do just fall out. So just remember to keep an eye on that. You might, if you tip them 45 degrees, they tend to lock themselves in a little bit, so they don't want to fall out. So maybe that's a trick to that, is to put them in a little bit like that. And yeah, okay, there's nothing else to watch out for there. Just drop it down, get it aligned nicely, and that's straight on, no issue. And again, don't do them right down until you got them all in. nothing in there. Hopefully I've been shot still. It's probably safe to tighten these up actually, because they're probably okay. It feels like it all lines up alright. There you go. Those feet pop back in it. Countersunk there. Okay, well done. Let's fire it back up, double check it's all working. Wait for the generator. Let's set to 1.2 volts peak to peak right now. That's fine. Turn it on. We'll get this running on. Where are we at? What I'm looking for? I've forgotten. Anyway, right. Trigger. We want set up trigger channel 1. Here we go. And all good. So as you can see, that's absolutely fine. No issue. And let's put it down to 2 volts again, which is where it was just now actually, and go 12 volt peak to peak. Oh, that's not the right one. How do we get to that? Cancel. Level. 12 volt peak to peak. There we go. And again, still fine. Alright, there's a little bit of rounding there, but when you got the example waveform, it's a bang on match. Now if I went up too much on that rising edge, then it started to curve upwards, so that's about as good as it's going to get on that calibration there, so that's all fine. Until again, just double check that. There is, it's not that hard to get it apart to do a calibration, as you saw. You've got to take the casing off, top panel off, and then you can do the calibration. You probably don't have to touch the back one actually. You might be able to do it without taking it off. So let's go to channel 2 again. Oh. Go on. Right. So yeah, that's fine. Absolutely fine there. 1.2 volt. Oh. Get right. 1.2 volts. And 200 millivolts, yeah, that's fine. No issues at all. So that's good. I'm happy with that. So that's how you do it. So hopefully that helps some people out there with their 1202X-E scopes, which have the compensation issue. And that's how it's done. It's a little time consuming. If you're used to doing alignments, then it's probably going to be a simple task to you. I do a lot of alignment work for doing radio work, work on CBs and that, so alignments are not unfamiliar to me, or the test equipment I even work on, so not a problem. Some people it's fairly new to them, so it's going to be a little bit uncertain, but as you saw, it's just 2 adjustments on each channel. 1.2 volts, 200 millivolts, number 1 adjustment, which is the one close to the front, and the 12 volts peak to peak on 2 volts per division, number 2, which is one further to the back, and it's as simple as that. It's not a hard calibration to do. The hardest thing is doing that soldering, getting those parts in there nicely without potentially damaging anything nearby or bridging traces, that kind of thing. As long as you're reasonably good at soldering, good enough to do surface mount soldering, then you'll be right. If you've never done surface mount soldering before, then I recommend you do not do it. Get someone that does do surface mount soldering to do it for you. You can always do the calibration yourself once they've soldered the parts in. But yeah, it's a bit tight in there. I've got a SMD tweezer iron, which would be perfect for this. but you can't get it in there. So there's actually not enough space between the shield side of the shielding and the edge of the part. There's not enough gap to get the tweezer iron in there, so it makes it a little bit harder in those regards. You know, if you've got those tools, you can't use them, so you have to find alternative methods. So anyway, so it's a little bit tricky, but not that hard. I mean, I didn't really find it challenging at all. It was interesting, but you know, I've been doing electronics since I was 7, so you know, what do you expect? Okay, so that's a good one. So all done. Any comments, chuck them below. Don't forget to look at the documents, download them from the thread from Taltech, and read that thread as well. I recommend you read it. There's some interesting information there. There's also some people being quite scathing, unnecessarily so. I mean, all manufacturers have issues with their product from time to time. You know, I don't always get it exactly right, and they need correction, which is what this is all about. So, you know, don't be too hard on Siglent, because they will actually at least give you the parts, and if you bought a new one, you can actually send it back and get another replacement. But yeah, it's one of these things. Some people think that's not good enough. Anyway, so the thing that so this is a demo unit. I actually saw the serial number on this, isn't this? Yeah, so this is the BAX, right? BA serial number, right? So BA is the first generation that came out. These are the ones, you know, the very first lot off the lines. So if you've got a BB serial number, it's also over here BAX, right? So if it starts with BB, you're absolutely fine. You don't have this issue, because those units have already had that capacitor fitted at the factory, right? But the BAs are the ones which potentially have that problem. If you're not sure, do those voltage checks like I did just now in the calibration. If it looks absolutely fine, then it's probably already been fixed. Okay. It's, you know, because there are BA models out there which have been reworked already. So just because it's a BA serial number doesn't mean it's got an issue, so it may have already been sorted out, like I've just done with this one. Okay, so thanks a lot for watching. Catch you later. Give us feedback and share this video to people that may be interested in it, that sort of thing. And catch you later.